Let's go over what I feel is one of the most unique features of my setup. We're going to take a dive into the targeting computer and see how we can get another player's point of view in real time. In this video, we're going to go over how what I call stream integration works with my setup and how you can build something similar for yourself. By the time we end this video, you'll not only know how to get another player's point of view in real time in a game, but also why you'd want to do it in the first place. Do you remember the days of old school split screen multiplayer gaming? I might be dating myself a little with that reference, but when all of the players shared a screen, you could easily look over their quarter of the screen to see exactly what they were doing and at a glance get an idea of where they were. This was called screen peeking and annoyed anyone else you were playing with if you tried it. If you were at a LAN party playing as a group, you could take a quick look over at your ally's monitor for about the same effect. That is, using it collaboratively instead of against the person next to you. What if we can take a modern approach to this same idea and use today's tools? In a world where online gaming rules and people seldom gather in person to play, it's eliminated the ability to physically look over at someone else's actual screen. When I first started this project, I thought I was going to be initially limited to a second local machine, either using a capture card or cloning the screen from a second local PC. At the time, streaming services simply weren't up to the task, at least to be useful in this context. There needs to be low enough latency to make it appear to be simultaneous. This has all changed, and now small-time streaming and screen sharing is able to keep up. Discord is perhaps the most widely known one, and if all you want to do is see another player's point of view, you can easily drag their stream over to another monitor. However, as you may have guessed from my setup, anything other than integrating this as fully as possible simply wouldn't do. And there are a number of technical problems that we'll have to solve in order to get it working. Before we go into those details, let's look at why you'd want to do this. Seeing another player's screen opens up tactical advantages. Seeing a turret gunner's point of view allows you to get an accurate idea of where they're firing, giving you a better idea of their firing arcs, allowing you to compensate for the motion of the target, and optimize for cover. Obviously, this isn't a replacement for good communication, but it can certainly be used to enhance and dial in callouts. This is going to work best with a good crew. It can be also used to fine-tune exact positioning, allowing you to get on target faster, and to get access to angles that are tricky to dial in otherwise. At higher speeds, this can be less useful, but still interesting to observe. A player can share their third-person camera view in order to give you a better awareness of your surroundings. In this example, it can be used as a landing camera from a player who has otherwise nothing to do in this situation. It can be used to view squads getting boots on the ground. For command and control of real-time mission monitoring once they're there. And coordinated close air support for the troops on the ground. Because we have the data being displayed on the different screens, we can wrap it all together into one nice gameplay package for streaming and recording. So why not just use an in-game camera instead of bothering to set all this up? Not every game is going to let us view things at every angle for a single player, or even can support rendering two scenes at once. Even if it does, we can't always export it to a second monitor, and sometimes the game camera option is not even what we want. By using this method, we can make it work with any game. Look at how comms calls work in Star Citizen. Well, just ignore the lovely face of this Vandal calling. Look closely behind our Vandal friend. The environment it shows, if you look in detail, is not actually a perfect recreation of where they are. It's a recreation that my client is making of where it thinks he is. Notice the pop-in of walls and flat textures acting as a pseudo skybox? Even if we could turn the camera around, it still wouldn't give us what we're looking for. Wouldn't it be a lot more useful and better if comms calls worked like this? Exactly what the other player is seeing and what their client is rendering, camera being spun around 180 degrees aside. It gives us much more specific and accurate information. I'm not saying they can't be improved in the future, but this gives us access to this type of setup today. So, whether you're using it to fine-tune a firefight, or using it to manage multiple players for mining, it can be used to enhance awareness, complement coordination, and increase immersion. As I am so fond of doing, let's take this one step further. Let's not rely on a display that requires us to take our eyes off the action, even for a moment. In the gameplay clips you've seen so far, this is the display that I am looking through. It's capable of projecting a semi-transparent image in front of the main display. It's hard to capture this accurately on camera, but think of it like looking at a window and seeing your own reflection in the window. By changing the focus of your eyes, you can choose to look at the reflection or what's past it. Because it's mounted on an articulated piston arm, it's able to be positioned wherever needed, either to the side or directly in front of my vision. This means, without turning my head, I have access to both what I'm seeing and what another player is seeing. I call this the targeting computer for what might be obvious reasoning. This works because of a piece of glass that's placed at a 45-degree angle in an enclosure with an LCD screen. This is known as a Pepper's Ghost hologram. Although not a true hologram, it is commonly referred to as such. It's commonly used in heads-up displays and teleprompters, as well as stage shows and tricks. In order for this to be the most effective, we need to use specialized glass known as beam splitter glass or plexiglass that has been treated to eliminate double reflections. Without this, you will have an image that is blurry. Here's a comparison between a regular sheet of plexiglass on the right and a treated sheet on the left. This glass also has a bonus property. It's 70% reflective and 30% transmissive, meaning that 30% of the light from behind it gets through and it reflects 70% of the light that's hitting from the LCD screen on the bottom. Because we're reflecting a screen, like a mirror, against glass, we're going to run into a problem where the image is going to be flipped. Let's take a look at this sample image and transpose it onto the targeting computer without compensating for the reflection. Just to prove that there's no trickery here, I'm rotating the targeting computer around so that you can see the LCD screen at the bottom. As it moves upwards, you can see the reflected image is reversed. This makes right, left, and left, right. As mentioned earlier, this is one of the reasons why we simply can't just take a Discord window or another streaming window and move it onto the targeting computer in order to get what we want. It's going to be reversed. We're going to need to compensate for this if it's going to be useful. The first option is to use the display itself. Not all displays support this option, but some have the capability of flipping the image around on their own, regardless of what is being displayed on the actual display. Now, whatever we want to have on the targeting computer is automatically oriented correctly. You can see this because even the on-screen display flips. Another option is using a virtual projector through streaming software like OBS. We can apply a horizontal flip to it so that when it appears on the targeting computer, it is oriented correctly. As you'll see later, because we're going to be using OBS to do our full integration, this is incredibly useful, as we're able to use the same software to manage, display, record and stream, and do our projection flipping. The final and most expensive option is to use a video converter unit that has the capability of flipping the image. Like flipping it on the display itself, a video converter eliminates the need for software and can provide several video enhancements. However, they can be quite expensive. Let's deal with a separate set of technical issues that are going to arise regardless of if we're using a fancy display or just a regular secondary monitor. Once we've tackled these issues, we'll be ready to move on to full integration. Earlier, I mentioned the simplest implementation was to drag a streaming window to a second monitor. But what if that player's aspect ratio doesn't match your monitor? Imagine that the video you are watching now is a viewable area on your monitor if you are not watching this in full screen. The most common aspect ratio is 16:9. Whenever someone streams their game, they are capturing whatever is on their screen and sending that data as is. If it is at an aspect ratio that doesn't match the monitor you are going to be displaying it on, it will not fill the monitor that you are using. As the aspect ratio becomes wider, the image will shrink in vertical height. So we won't get the most use out of our display, and anything that's in the center of the screen will become harder to see. You could always ask someone to stream in the same aspect ratio as a display you're going to be putting it on, but we want to make it as convenient as possible and not have to worry about any kind of setup on someone else's end. This is where OBS comes in again. If we capture the stream window using OBS, we can scale it appropriately and then use a virtual projector to send it to another display. This will correct for the aspect ratio difference. This is basically the same thing that I did to build the custom minimap display for PlanetSide 2. By scaling, cropping, and masking various components of the screen. And then finally, using a virtual projector to place it on another display. Now that we have all of our stream data in one spot in OBS, we can fully integrate everything into the setup. We have multiple users' streaming data combined together into one stream and one recording that gives us gameplay from many angles. Through the use of OBS's virtual projectors, we have that same data displayed on our own displays inside of the cockpit. Managing this together, all within one program, it keeps the overhead as low as possible. But let's solve one last problem that truly completes this setup. If we want to avoid the inconvenience of alt-tabbing in and out of game in order to change what's on those displays, and avoid changing the input on the display itself, which can cause the screen to flash and the display's overlay to cover part of the screen. If we are clever with our scene setup in OBS, we can use hotkeys to show and hide various elements on each of the virtual projectors that are being displayed on each of our displays. This means with a push of the button on the targeting computer, I can control which user I'm seeing. Or, in this instance, even both. I can even control which streams make it to the combined stream. and have that simultaneously reflect what I'm seeing on the targeting computer. And this is what allows us, at a push of a button, to be able to change what's on the displays. No alt-tabbing, no manually moving windows, no disruptions in the middle of gameplay. And with everything set up, we can have the projectors load automatically by enabling the settings within OBS. Thanks very much for watching, and thanks to everyone who helped me gather footage for this video, whether it was from gameplay or for gathering footage for demos. You can see their names at various points in the top left-hand corner of the clips used. Let me know in the comments how you might use this to enhance your own gameplay, and share it with someone for whom you think it will be useful for. Please consider subscribing for more tech and gameplay.